To verify this identity, I'm going to start on the left side and get a common denominator. If I have secant theta minus 1 times and secant theta plus 1, the common denominator would be their product. So my common denominator is going to be secant theta minus 1 times secant theta plus 1. So if I look at my first term, it already had a denominator of secant theta minus 1. I had to multiply by secant theta plus 1 in the denominator, so I have to multiply by that in the numerator as well. And 1 times secant theta plus 1 is secant theta plus 1. For my second term, I had a secant of theta plus 1, and so I have to multiply by secant theta minus 1. And if I multiply 1 times secant theta minus 1, I'm going to obtain secant theta minus 1. So now in my numerator, I have secant theta plus 1 plus secant theta minus 1. Combining the ones, they equal 0. So I have 2 times the secant of theta. And in the denominator, secant theta minus 1 times secant theta plus 1 is a difference of squares. So I'll have secant theta squared minus 1. And if you think back to one of your Pythagorean identities, 1 plus tangent squared equals secant squared. So a secant squared minus 1 would be equal to a tangent squared. Now we have simplified our problem sum and gotten a common denominator, but if we go back and look at the other side, we're trying to end up with cotangents and cosecants. So let's rewrite what we have so far. We have 2 times the secant. So secant is equal to 1 over cosine. And we're dividing that by a tangent squared. A tangent squared is a sine squared divided by a cosine squared. And when we divide with fractions, we multiply by the reciprocal of the divisor. So let's flip the second term, and that would be cosine squared over sine squared. And then we have a factor of cosine in both this denominator and this numerator, so we can cancel one of those out, and we'll end up with 2 times the cosine of theta over sine squared of theta. So looking at the other side to see what we need a cotangent. Cotangent is a cosine over sine, and we need a cosecant, which is 1 over sine. So we could continue to change this to be 2 times the cosine of theta over the sine of theta times 1 over the sine of theta, just breaking apart that product. And then cosine over sine is our cotangent, and 1 over sine is our cosecant. So we have proved the identity because the left side is indeed equal to the right side.